Hello everybody. We're going to continue here with solving trig equations. We're going to take a few more problems. So number 11 on page 260. I guess before we start with this, I want to point out the interval that we're solving over. So this means that my answer has to be between 0, including the 0, and 2 pi, but not including the 2 pi. So we have a square bracket here, parentheses here, inclusive, non-inclusive. My answers need to be in radians. I think I forgot to point that out in the last video. So we're going to start here the same way. We're going to subtract 3 to isolate the trig function. And we have tangent squared of x equals -3. And when we go now to undo the square, we're going to take the square root of both sides. And take a look at what we have here. We have now the tangent squared of x, so square root of that is tangent of x, and then equals the square root of -3. So we know from back in Algebra 2 that this is going to result in an imaginary number, and an angle cannot be imaginary. So this problem has no solution. Our angles cannot be an imaginary number. For number 13, this problem is nicely factored for us. So when a problem is factored, we can simply use our zero product rule and set each factor equal to 0. So our cotangent of x minus 1 equals 0, and rad 3 cotangent of x plus 1 equals 0. And now we can solve both equations here separately. We have cotangent of x equals 1 on the left, and over here we have rad 3 cotangent of x equals -1, and we're going to divide by the radical 3 in order to isolate here. So over here we still have a little bit more work to do. We want to rationalize. We don't want to leave that radical in the denominator. So we're going to rationalize by multiplying by rad 3 over rad 3. So we have cotangent of x equals negative rad 3 over 3. So thinking about where this happens on our unit circle, if we come back over here to the left, cotangent is the reciprocal of the tangent function. So we could also say that tangent of x equals 1 over 1, which is just 1. So thinking about our unit circle where tangent of x is equal to 1, we know that that is going to happen where the sine and the cosine are exactly the same. And that happens at our 45-degree angles in quadrants 1 and quadrant 3, because we know we're going to have rad 2 over 2, rad 2 over 2 for this ordered pair, and negative rad 2 over 2, common negative rad 2 over 2 for the ordered pair in quadrant 3. And when we divide these by themselves, the sine divided by the cosine, we're going to get 1. So our x here, so we have to think about our interval being in radians, so our answer has to be in radians. We're going to have pi over 4. And the other one, so this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 over here. So that's 2 of our answers. Now we have to come back over to the other side and think about where cotangent of x is going to be equal to negative rad 3 over 3. So again, if we even want to think about this in terms of tangent, tangent is the reciprocal of cotangent. If I take the reciprocal back here, I'm going to get a negative rad 3. And if I think about my special right triangle, here's my 30, my 60, my 90. We have 1, we have rad 3, and we have our 2 here. So the angle that we're talking about for where the tangent is equal to rad 3, it's the opposite over the adjacent. So if I'm looking at my 60-degree angle, opposite is rad 3, adjacent is 1. So I'm really talking about my 60-degree angles, but I'm talking about where it's negative, okay? So we're really going to be looking at this one over here and this one over here. So if we think about the unit circle, we have -1/2, comma, rad 3 over 2. And over here, we have -1/2, comma, negative rad 3 over 2. So sorry, I guess it's not this one, it's actually this one. So we'll come back over here. So 1/2, comma, negative rad 3 over 2. This is what I want. I need the signs to be opposite in order to get that to be a negative. So I'm going to cross this one out over here. So the angles that we're talking about, they make a 60-degree angle, reference angle with the x-axis. So we have 120 degrees, or 2 pi over 3. And this one over here, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So I have 4 different angles that satisfy this equation. And that's it.